Hey everyone, and thanks for tuning in to the video titled, What's the Use of Standard Form? I get this question a lot. In our last lesson, I had you toggle, quite literally, between a line in slope-intercept form, y equals mx plus b, and I had you rearrange that into standard form, ax plus by equals c. And students over the past years have said, what's the point? I like this better. Slope-intercept form tells me so much more. I can graph so easily. I can just go to my y-intercept and then I can rock out the slope. So what the heck is the deal with standard form? Well, I'm here to tell you today. And what I did is I just chose one example. So if you're working off my notes packet, in the packet, what's the use of standard form is where we are. And I just chose example 2. But if you go through example 2 with me here on the video, you'll totally be able to do the other examples. I wanted to make this video a little bit shorter. So what's the use of standard form? Okay, so here's the argument, okay? Coming from an Algebra 1 student's perspective, if they were given standard form, here's the argument. I can just take standard form, 3x plus 4y equals 12. I can turn it back into slope-intercept form and be on my merry way. In other words, I could solve for y, so I could minus the 3x from both sides, giving me 4y equals negative 3x plus 12. And then I could divide everybody by 4 to give me y equals negative 3/4 x plus 3. And from there, I could easily sketch the graph. I would simply draw a y-intercept at positive 3. 1, 2, 3, right? And then I could rock my slope out by going down 3 and right 4. So 1, 2, 3, 1, 2, 3, 4. And if I wanted to go the other direction, of course, I could go up 3, left 4. I only like to go left when I'm doing the opposite. So there you have it. So if you can just do that, then there you go, slope-intercept. So what the heck is the use of standard form? Well, here's the counter argument, okay? So my counter argument would be that there is a use of standard form. Actually, if you're given an equation in standard form from the get-go, you can get this graph without doing any of this work by identifying the x-intercept and the y-intercept. So let me show you how that works. So I like to make a little table, if you will, x versus y, like that. And I like to identify the y-intercept and the x-intercept. Now let's go over the definitions of those. So the y-intercept is the value of y. So that's what we seek. Where the line is going to cross the y-axis. So I want to know the value of y where the line is going to cross the y-axis. The x-intercept, on the other hand, is the value of x where you're going to cross the x-axis. X-intercept intercepts the x-axis. Now, we have to figure out what we can put here and here in order to find these boxes. So let's dive into this a little bit further, y-intercept, x-intercept. So let me go to a separate sheet of paper. Let's look at a graph of a line. Okay, this is the x, this is the y. Say the line looked like this. I'll make it in red. Okay, let's look at the y-intercept. I think we would all be in agreement that that right there is the y-intercept. Maybe I draw a different line. Maybe my line's down here. Now my y-intercept is there. Or maybe I'm down here. And maybe I have a negative slope. Maybe this line goes this way, and that's the y-intercept. I want you to think what all of these y-intercepts have in common. What do y-intercepts all have in common? You can think about that. You can put me on pause. Let's give it a go here. If I were to write the coordinates of this y-intercept, I don't know exactly what it is, but wouldn't it be something like 0, maybe 3? Maybe that's 0, 3. Maybe this one is 0, 1. Maybe this one is 0, -4. Do you notice how, in order to stay on the y-axis or to intercept the y-axis, your x has got to be 0? Because here's the deal, guys. If you move to the right or to the left on the x, you're no longer going to intercept the y-axis when you move up or down. You're offset. But if you keep the x steady at 0 and then move with your y, you're most certainly going to hit the y-axis and intercept it. So when I go back to my table, it's really simple. To find a y-intercept, it's the value of your y, where you cross, when the x stabilizes at 0. So check out how easy this is. Go to your standard form. Fill in 0 for the x. It would look like this. 3 times 0 plus 4y equals 12. Now 3 times 0 is 0, so that's a wash. 0 plus 4y is still 4y equals 12. And when you divide both sides by 4, your y-intercept sits at 3. So 0, 3. Now come down to that graph we graphed earlier. 0, 3, let's look. Are we at 0, 3 for the y-intercept? We sure are. So we would plot that point on the graph. Okay, now let's talk about the x-intercept. Well, shush this down a little bit here. If a graph's x-intercept is going to come on the scene, then we're going to be looking, let's say this is my line, right? We're going to be looking there. That's where that line intercepts the x-axis. Or maybe here. That would be the x-intercept. Or even this. And you could always have a negative slope as well. You're still identifying the line's x-intercept. So what do these have in common? Well, let's have a go at it. Let's see, this ordered pair here would be, I'm just guessing, maybe like -3, 0. This might be 1, 0. Maybe this is like 7, 0. What do they have in common? Well, I hope you're thinking the y is 0. See, you want to move to the x, right? You want to move around here to move to the x, but once you're at a certain x, you don't want to lift up or down any on the y. You want to stay put on the y. Otherwise, you're not on the x-axis anymore. So to find an x-intercept, the y has to be 0. So let's go back to our table again. So in order to find an x-intercept, it's the y value that has to be 0. So if you fill 0 back up in standard form, but you put it for y this time, you're going to have 3x plus 4 times 0 equals 12. That's 0, so that's a wash. So now you have 3x equals 12. Divide by 3, and x is 4. So 4, 0. Let's look at the line here and see if it actually did cross the x-axis at 4, 0. Well, sure enough, it does right here. 4, 0. So here's the idea, guys. I know I have a lot of work on this paper, but the overall idea is this. The use of standard form is simple. Go back to the beginning. The equation in standard form was this, 3x plus 4y equals 12. The use of standard form is, you make a table, you find the y-intercept by letting the x be 0. See the opposites? Y-intercept, you let the x be 0. For the x-intercept, it's the opposite, you let the y be 0. You can do this quickly in your head. Fill in the x. 0. That's gone. 4 times what makes 12? 3. 0, 3. Now you let the x be 0. The y be 0. Now you let the y be 0. That's 0. So this is now gone. Now you have 3x equals 12. So clearly x is 4. You sketch a quick graph. You plot the point 0, 3. 1, 2, 3. Got it. You plot the point 4, 0. 1, 2, 3, 4. You connect the dots. You've got the line. There's no need for slope-intercept form. You did the graph with standard form. So that's the use of standard form. You can sketch a quick graph by finding the intercepts. So hopefully you have a better appreciation of standard form. It's also good for solving systems of equations, which maybe you've seen or you haven't. But yeah, so that's the deal. Thanks for watching, and good luck with your mastery.